Oh, hello. This is the second lecture in which we will discuss a little bit the solid principles of object-oriented programming that will allow us to explain some of the things that we will work on later. We also will talk a little bit about the basics of the REST API that we will use throughout our course and about some other good practices of object-oriented programming. So, first thing that we probably remember about object-oriented programming is the 4 pillars of object-oriented programming, which is abstraction, encapsulation, inheritance, polymorphism. I assume, I assume that those 4 elements, whether this is Java language, C# or any other objective language, are known to you. So we won't be discussing them that much. But remember that all those 4 elements are kind of allow us to implement certain things that we'll talk about later. Yeah. So we won't be discussing this, but remember this is the 4 kind of pillars that we will build upon when talking about some other things like solid principles. But today we'll talk about solid principles. Solid principles is actually a set of rules related to object-oriented programming. We could call them good practices, and so on. They were first conceptualized by Robert C. Martin, also called Uncle Bob, that maybe you know, someone who is pretty well known when it comes to object-oriented programming, who is still publishing posts. And he, in his 2000 paper, Design Principles and Design Patterns, describe certain things related to object-oriented programming. You can find the link to this work in here. And those concepts were later built upon by Michael Feathers, who introduced the SOLID acronym. Now, what is this acronym? The acronym is just a few rules that are supposed to help us creating more complex and maintainable solutions. So those rules allow us also to create solutions or software that is flexible, which means it's easy to change certain things and it's easy to extend it without modifying and destroying what we already built. It's easy to fix bugs. It's also easy for other developers to come into the project and understand what's going on. It's easy for us after a week or a month to understand what's going on. So those solid principles are actually guidance in a way for us how to build and how to structure our code. However, it's not, let's say, but it's not a mathematical kind of rules. It's not a mathematical formula. So it's not that easy to conceptualize how we should implement certain of those rules in certain cases. So we will discuss and see example of it, and we will often go back to those rules, to this acronym, and mention that, let's say, in this example of .NET related libraries, they use this and this pattern, and you see that's why, and so on and so on. So we often will go back to it. Now, those 5 rules which are represented by the SOLID acronym are single responsibility, open closed principle, list of substitution, interface segregation, and dependency inversion principle. So we will go step by step now and try to explain what each of those actually mean. The first one is single responsibility. We will see it very often. I would say that probably this is one of the most important elements. Single responsibility is pretty vague when you read this rule first time, which simply means that class should have only one responsibility and or class should have only one reason to change, whatever that means. What it means? The question is, what is this responsibility? Responsibility actually, maybe I will. Okay. Second, maybe I will move it here and put it here. Okay. Never mind. Okay, responsibility. When we design an object-oriented programming, we have a few ways how to structure the code. First of all, we have methods. We put the methods inside classes. Then classes are put, let's say, when you talk about Java, it would be packages. When it when we talk about C#, we mean namespaces. Namespaces are then put into projects. And all of this grouping of the code means that usually we have a few classes that are within the same namespace. Maybe in the same namespace we have some other classes. Then we join those two things with inside a component or a separate project, and so on and so on. So we group the code somehow. Now the question is how to group this code. Why we put two things, two similar things in the same class? Turns out that it's not an easy thing. When we structure our code, create methods and so on, it's not that easy, especially if we are dealing with the complex domain, business domain. It's not easy to make sure whether those two things come together in a single class or not. Now, when we have a class, we should make sure that this class is responsible for handling a very specific thing. Let's say I have a class called student, and this class contains properties like first name, last name, and so on. And we should make sure that this class only is interested in creating and managing the student data. We shouldn't, for example, put inside of this class things related to maybe teachers or some other entities. Yeah? It does seem pretty vague. So one thing, we have to kind of understand the business domain and see what can be kept together and what shouldn't be kept together. Second thing, very often we divide the code between classes based on the technical part, so based on some implementation responsibilities. So an example of it will be as follows. As we discussed, this rule is one of the most important ones, but I will show you an example. So we have a single responsibility principle here, and let's take a look. We have a class. Class is called book. We have the name, author, text, and so on. This element in here, if you haven't worked with C#, is called a property. So it means basically that this is basically getter and setter for the name property, just like in Java. So we have three fields in here, name, author, and text. We have the method called contains word that allow me to check whether this book contains this word. We have a replace word method. We have the method called save to file that allow me to pass the path and just save this somewhere. We have the print to console that allow me to print some code to the console and so on. Now what we have in here actually, we have a single class that mixes a lot of different responsibilities, which may be not very clear for us. Responsibility usually means one of the two things. Either this is some kind of business domain responsibility, or it's some kind of technical responsibility. For example, saving something to the persistent storage. It's not necessarily a business, it's not necessarily a business domain problem, but it's some technical part that we have to implement. So in this case, I have a book that a sole responsibility of this class should be managing the information about a single book. And I have a method that allows me to save something to the file to the persistent storage, which shouldn't be usually the responsibility of the class modeling some kind of business domain element. And next one, printing to the console, which also should be rather a responsibility of a different class. Why? Because we assume that very often we would like to print, let's say, this book to some different thing than the console, and very often maybe we would like to save this book to some different place than the file path, than the file system. So there is also high chance that those portions of code will be modified. Secondly, they're not necessarily connected when it comes to the business domain with what we have in here. Contains word and replace word is exactly connected with the book. Those two things have kind of high cohesion. High cohesion means that if we are dividing the class, if we're building a class, we should strive to what is called high cohesion versus low coupling, which means that elements in this class can be connected with each other in a very concrete way, let's say. Contains word is using the text property, and those things are using each other. They are cohesive together. And that's good that they are in the single class. Now, low coupling means that we would like to divide our code into separate classes so that we have between different classes, if we will create some kind of UML diagram, we have as little connections as we can. So if you have classes, let's say you have 2 classes or 3 classes, and there's extremely large amount of connection in between different classes, then it means that the coupling is pretty high. Those classes always have to be used together, which is not usually a good thing. We will talk about it a little bit later. So what we should do, we should most likely move away the logic for printing the book to the separate class. Maybe we could call it book printer, that allow me to print to the console, to the screen, and so on and so on. Of course, I could divide this code in a very different way. However, I put the text saving capabilities to a separate class called text file saver. Or actually, I could call it just text saver, which have a method to save to DDB, save to text file. I could just move all the basically saving logic to a separate file, and inside of the book, leave only the things related to the book. Yeah. So it seems pretty vague for now, but we will see a couple of the examples from the .NET platform and from our applications how we can divide such logic. What is usually considered a separate responsibility? Of course, sometimes we may have a situation where it's not really that easy to distinguish whether something should be separate or not, but we will discuss it nonetheless and see the result. But just remember, when we are designing a method, this method should do one specific thing. So we can say that single responsibility can be a guide towards every portion of the code we write. If we write a method, this method should do one single specific thing. If we create a class, this class should manage and do a specific type of things. If we will create a namespace, or let's say namespace, or the package in Java, this namespace should store classes that are somehow connected with each other in some way, and so on and so on. So this is single responsibility principle. It allows us to first, it can be used on a class level, method level, and component level, on every level basically. Secondly, we will later use that using correctly this rule will make testing easier. It will be easier to write automated tests. Then it will improve the organization of our code. It will be easier to extend our code, find bugs, and so on. And splitting the code in this way also promotes code reusability. So if you will split the code correctly, we have much higher chances that some of the code could be just repeated and used in multiple places. Now, next example here, we have the same example kind of shown. So I will switch and go to the next one. Now the real world example, for example, of the single responsibility principle. There are a lot of examples because this single responsibility principle is used basically throughout .NET platform, and we should also use it. For example, we will be connecting to the database. Now, we will often see that that class that is responsible for managing the connection which is called SQL connection, let's say, and a class responsible for actually, which represents the SQL command, and a class that represents SQL connection to database are two separate classes, as we will often see. So this is a typical example, let's say, that managing opening the connection, closing the connection is a responsibility of a separate class, and just representing the specific SQL command, sending this command, parsing the result, is responsibility of another separate class. So, for example, when it comes to databases, we'll often see that connection and command are two separate classes with separate responsibilities, so they will be split. Now, next one is the open-close principle. Now, this principle means that classes should be open for extension but closed for modification, whatever that means. So it means that we should stop ourselves from modifying existing code and causing potential new bugs. Exception is the rule of when fixing bugs in existing code. What it means basically? It means that if we have some kind of a code and this code works and our clients are using this code, then it means that if there will be some changes to this code, we would like much more to extend this code than modify the existing code. So we should rather add new code then modify the existing one. This means because if we modify the code, we have much higher chances of introducing some kind of a bug than when we just add a new code to the project. So this principle is trying to promote adding new code over modifying the existing one. Yeah. Of course, the exception is fixing bugs in the existing code, of course. So what is the example? Let's say that we have a person. This is a very simple example, of course. We have a person class, and let's say that our application is used for manage Dean's office and so on. Now, after some times, it turned out, maybe after a month or half a year, that we have to include some additional properties for the student and additional one for the teacher. So I modified the person class, and I added the fields for the student, fields for the teacher. I added some methods only for the students, only for the teacher. What it means only for the student? Well, it means that if the specific person will be a student, then all the teacher values in here, position will be null and salary will be probably 0 for this kind of teacher. If someone is a teacher, then his index number will be null and specialization will be null also. The problem is that in here, because I wanted to introduce new code, new properties, I modified the person class, I added some methods, maybe I modified some older methods, and it could break the code that already uses the person class. So a better fit would be, for example, to keep in the person class only methods for a person and use the inheritance to introduce 2 new classes that represent student or teacher. Yeah. So I added a new code, and I didn't modify at all the person class. I left only the things related to the person class inside the person class. So this way I added a new code. And usually those types of things will help us to promote and to not introduce bugs in a system by adding a new code. Now I have to just write some new test for this code, test it, and that's it. If I modify this code, I have to again basically check all the tests and test this portion of the person code once again. So we can use inheritance for that, but there are a lot of different other ways of actually introducing the change to the code by extending it instead of modifying. So inheritance is one way, but we have quite a few others. So open close mean how we can extend our application without introducing modifications in our code. Now, Liskov substitution is another element that is basically part of the language, and you already know how this principle works. But this principle is very important because it allows us to create code that is very generic. It was introduced in 1987 by Barbara Liskov, and the rule itself means that derived or child classes must be substitutable for their base or parent classes. And we will see an example of that in a second because it may not seem that clear. Now, the principle ensures that any class that is the child of a parent class should be usable in place of its parent without any unexpected behavior. Now, what it means? Usually, we can use this rule or achieve it using abstract classes, inheritance, or interfaces. So this is usually the elements within Java or C# language that we can use to use this principle. Now, how it works? Let's assume that we have a class called student group. And this class represents a group of students, but actually here we have the list which contain which people are part of this group. And let's assume that a part of the group may also be a student or a teacher. So any of those 2 classes, student or a teacher, can be a part of the person, of the student group. Now here I use the person type, yeah? And I have just 2 separate classes, again, student and teacher. So how I can create a single collection that allow me to store teachers and student? Well, I can just use the base class, the base person type, and let's take a look at that here. If I will create a new student group and I will add a person, and this person is a teacher, this code compiles. If I will add another type of the person, which is a student, this also compiles. And this is because student group is using the base person type. So actually, this is true that every student is a person and every teacher is a person. So it means that in the place of this base class, I can use any of the derived or child classes, which is in this case student and a teacher. So the principle in our language works correctly. And this way I can put inside of this collection any type of person I want. And we will often use it. The same thing we could do if I would use as a type here, the interface, and I could put inside of this collection every class that implements this interface. Now, next one is interface segregation. This one allows us to basically split larger interfaces into smaller ones. And this way we can ensure that implementing classes only needs to be concerned about the methods that are of interest to them. What it means? It simply means that if we have interface, and let's take a look. I have the interface iBook, which represents a book. Every class that will implement this interface must have the title, text, author, description, but also they have to have print to console, save to file, save to database, get from database, and so on. What is the problem with that? This rule is about creating the interfaces that really encapsulate a cohesive logic together. In this interface, I have a bunch of methods that are not connected to each other. So if someone would like to create a book or a class that will implement this interface, then actually they will be forced to implement all of those methods, even though probably very often those methods will not be of interest to them. So what we should rather do, we should split this interface into a set of smaller ones. And actually this kind of problem is also visible in a lot of the built-in libraries, in the older .NET libraries also, that we have a very large interface. And if I want to use this interface, if I wanted to make public class book, I have to basically implement the whole interface like that. And take a look. It means that I have to implement all of this. And very often, some people were just leaving the methods that were throwing not implemented exception when it comes to the functionality that they don't use. Because they have to implement the interface, but they don't want to implement all the methods, and they just left something like this. So of course, this is not a good pattern. So remember that interfaces, basically, when you think of it, it's kind of like saying that the interface should have, again, a single responsibility. It should describe a single entity together, not just 100 of methods that every class will have to implement. And the last one, which is very important, and we will use it very often, because the mechanism for this for implementing this principle is actually built in within .NET Core Platform, is dependency inversion principle. Now, the principle of dependency inversion refers to the decoupling of software modules, and this is very important. Instead of high-level modules depending on low-level modules, both will depend on abstractions. High-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. What it means? First of all, what it means abstraction. When it comes to C# or Java-like languages, abstraction usually mean an abstract class or an interface, usually the interface. So let's take a look at the example. Let's say that we have two classes, person class and Oracle DB class. And person class has a reference to the Oracle DB. So in our case, it would look as follows. I have a person class, as you see, that have a first name and last name, but I also have here the field saying Oracle database of the type Oracle database, yeah? And I have the method save, and let's assume that this method in the person class just uses the Oracle database object to send some command to database, as you see, and so on and so on. So, of course, we could discuss the merit, whether we should at all keep the reference to some database logic within this kind of business domain class, but that's not a problem. The problem is that person is a high-level module, and Oracle database we treat as a low-level kind of technical part of our application, low-level module. And between those two classes, we have a very strict association. It means basically that we cannot use person class without Oracle database class, because person class depend on the Oracle database class. Person class depend on the concrete class, not on abstraction. So how we can fix it? Well, what we can do is we can introduce some kind of abstraction, let's say an interface saying iDatabase interface. This interface will force someone to implement the connection string, the connect method, and the send SQL method. Then Oracle database will implement this interface as you see in here and provide all of the methods. And inside of the person class, let's take a look, this is very important. I'm not using a concrete class, I'm using the interface. So it means that a person class depends on abstraction, which is this interface. So at the compile time, person class depends on abstraction, and this object is passed in the constructor. So what it means, why it's called dependency inversion principle, because now our diagram looks like that. Person class depends on the interface, and Oracle database implement the iDatabase interface. This is the order of the relations now, basically. What it gives us, it allows us to actually control how the person class behaves. Because now I don't have a hard-coded Oracle database inside person class. I can actually provide in the constructor of a person any implementation of the iDatabase. And this way I can, for example, pass SQL Server database or Oracle database or some other database. And I can control how the save method will work this way, which implementation will be used. So it gives us a lot of the possibilities, let's say. It allows us to control how we can exactly use this person class. So I can inject basically, this could be called basically a constructor injection. We can inject a class here, which means just passing through the constructor and assigning it. And also it's very important that if your class requires something to work correctly, like let's say this database, then the best thing is to pass it through the constructor. Because it's very clear now what are the dependencies of the person class. Dependency is iDatabase. This is what we needed for the person class to work correctly. Okay? So this is the dependency inversion principle. And again, we will see it very often while we will work together on different kind of projects. So remember, this is pretty important. Now, cohesion and coupling, we already discussed. High cohesion, low coupling, what it means. And during our subject, we will talk about different kind of apps. So nowadays, we could, of course, mention web applications, and among them web services, gRPC services, REST services, WCF, desktop app, console app, mobile apps, and so on and so on. All of those apps usually require some kind of database connectivity. Yeah, we will concentrate on different kind of web apps because this is what is the most prevalent today. And you already did some desktop apps on Java, so you already kind of know those type of apps. But we will concentrate on the web apps, on the API applications, and on the web application rendered on the server side. So this is what we will kind of concentrate a little bit more on, because that's the most typical kind of app nowadays.